Time feels simple. It moves forward. Moments pass. Memories stay behind. That is how life feels. But physics tells a very different story. Deep inside the laws of nature, there is no clear rule that says the past must disappear. No line that says yesterday is destroyed. No command that forces time to erase itself. This creates a quiet problem, a problem most people never hear about. If the laws of physics work almost the same forward and backward, then why does life move in only one direction? Why do we remember the past but never the future? Why does a broken cup never return to its original shape? The answer points to one powerful idea: entropy. This single concept explains why time feels like it flows, why change happens, why order fades into disorder. Richard Feynman, one of the greatest physicists of the modern age, spoke about this in a way few others could. He did not hide behind complex math. He stripped the idea down to its core. What he revealed is unsettling. The direction of time may not be built into reality itself. It may come from something far more subtle, the tendency of the universe to move toward disorder. This leads to a deeper question. If time itself does not destroy the past, then where did it go? Physics allows equations to be reversed. Atoms do not care about yesterday or tomorrow. On the smallest level, time has no preferred direction. Yet human experience is locked into one direction only: birth to death, cause to effect, memory without foresight. This difference between physics and experience is not a small mystery. It is one of the biggest unsolved questions in science. Some physicists believe the past still exists, not as memory, not as a recording, but as a real part of reality. According to this view, time is not a moving river. It is a structure. All moments exist together: past, present, future. Nothing disappears. Nothing is erased. We simply move through it. This idea is rarely discussed outside advanced physics, yet it changes how we think about memory, identity, and reality itself. Feynman approached this carefully. He avoided philosophy when evidence was missing, but he was clear about one thing. Entropy explains why time feels one way. It explains why we see change, but it does not prove that the past is gone. This distinction matters, because if the past still exists, then time is not destroying anything. It is only revealing one slice of reality at a time. In this video, you will learn how entropy creates the arrow of time, why physical laws do not forbid the past from existing, and why the feeling of time moving forward may come from memory, not reality. You will also hear how Feynman's simple explanations exposed a tension between what we experience and what physics allows, a tension that most people never notice. By the end, you will see time in a new way, not as something that steals moments, but as something far stranger. This is not speculation. This is grounded in real physics, in real equations, in ideas taught at the highest levels of science. Stay until the end, because the final idea changes how everything fits together. Welcome to the channel. This is where science meets the deepest questions about reality. If you enjoy clear explanations of complex ideas, subscribe and stay with us. Time feels like it moves in only one direction. We remember things that already happened. We never remember things that have not happened yet. Memories stack up behind us. The future stays empty. This feels natural. It feels unavoidable. Everyday life supports this idea. A glass falls from a table. It shatters on the floor. The pieces scatter. No one has ever seen those pieces jump back together. No one has seen the cracks seal themselves. The glass never returns to the table on its own. Food cools down after it is cooked. It does not heat itself back up. Smoke spreads through the air. It does not gather back into a tight cloud. Life moves forward. People grow older. They do not grow younger. These patterns feel so strong that they seem like laws of nature. It feels like time itself is pushing everything in one direction, but this feeling is not the full story. Physics does not care about human experience. It does not care about memory. It does not care about emotion. The basic laws that govern particles and forces work almost the same forward and backward. On the smallest scale, most equations do not choose a direction for time. This creates a strange tension. If the laws do not force time to move one way, then why does everything around us do exactly that? This question bothered some of the greatest minds in science. One of them was Richard Feynman. Feynman was not interested in complicated language. He believed that if you truly understood something, you could explain it simply. He taught physics with curiosity and honesty. He questioned ideas that others accepted without thought. Time was one of those ideas. Feynman noticed something important. When people talk about time moving forward, they often mix physics with experience. They assume nature must behave the way life feels. Feynman separated the two. He asked a deeper question. Not why time feels one way, but why the universe allows it to feel that way at all. Again and again, his thinking returned to one concept: entropy. Entropy is not mysterious on its own. It does not require complex math to understand its core meaning. Entropy is a measure of disorder. Order means things are arranged in a specific way. Disorder means they are spread out and mixed. Over time, order tends to fade. A clean room does not stay clean. Dust settles. Objects shift. Small changes add up. A deck of cards starts in a neat order. After shuffling, the order is gone. The cards are still there. Nothing disappeared, but the arrangement changed. Heat behaves the same way. Hot objects cool down. Cold objects warm up when placed near heat. Energy spreads out evenly. This spreading is entropy increasing. Once energy is spread, it rarely gathers itself back, not because it is impossible, but because it is overwhelmingly unlikely. This is the key point. Entropy does not say something cannot happen. It says it almost never does. A broken glass could, in theory, reassemble. The laws of physics do not forbid it, but the number of ways for the pieces to stay broken is far greater than the number of ways they could come back together. Nature follows probability, not preference. As time passes, systems move toward the most likely state. That state is disorder. This simple rule explains a lot. It explains why heat spreads, why things decay, why structures wear down. It also explains why time feels one way. The past had less disorder. The present has more. Memory depends on this. A memory is a physical record. It requires change. It requires entropy to increase. You cannot store a memory without creating disorder somewhere else. This means memory itself points in one direction. We remember the past because records form as entropy increases. We do not remember the future because those records do not exist yet. Time does not feel one way because of clocks. It feels one way because of entropy. Feynman emphasized this idea again and again. The arrow of time comes from disorder increasing, not from time itself. This distinction matters because entropy explains why time feels directional. But it does not say anything about whether other moments stop existing. It explains change. It explains memory. It explains decay. But it does not erase the past. This is where the question becomes deeper. If entropy explains our experience of time, then the feeling of movement may not reflect the true structure of reality. Time may not be flowing at all. It may simply be ordered in a way that creates change. Feynman did not claim to know the final answer. He stayed grounded in what physics could test. But his explanations made one thing clear. The one-way feeling of time comes from entropy, not from a rule that destroys the past. And that leaves the door open for a much stranger view of time. The laws of physics are surprisingly neutral about time. Most of them work the same way whether time moves forward or backward. If a collision between two particles is allowed, the reverse collision is allowed too. If motion follows certain rules, reversing that motion does not break those rules. On this level, time has no preferred direction. Yet the world around us clearly does. The reason is not hidden in the equations of motion. It is hidden in entropy. Entropy does not behave like most physical laws. It does not run equally in both directions. It increases, not sometimes, not usually, almost always. This steady increase gives time its sense of direction. It creates a difference between before and after. This difference is called the arrow of time. The arrow does not come from clocks or calendars. It comes from the way disorder grows. When entropy increases, systems move from fewer possible arrangements to many possible arrangements, from order to disorder. This process leaves a trail. That trail is what we call the past. The past had lower entropy, fewer arrangements, more structure. The present has more disorder than the past. Energy is more spread out. Systems are more mixed. The future will have even more. This sequence creates stability in one direction only. Because of this, the past feels fixed. We can study it. We can record it. We can trace events back to clear causes. The future does not offer this clarity. The future contains many possible outcomes, many possible arrangements, higher entropy. As entropy increases, certainty fades. This is why causes point backward and effects point forward. A footprint tells you someone walked there. It does not tell you where they will walk next. A photograph records light that already scattered. It does not capture light that has not yet spread. Records only form when entropy rises. This makes the past readable and the future unreadable, not because the past is locked away, but because the information exists only in one direction. This creates a powerful illusion. The illusion that the past is solid and the future is open. Physics does not describe the past as frozen or erased. It describes it as a state with lower entropy. Nothing in the equations says those states must vanish. When physicists write equations, they do not remove earlier moments. They relate one state to another. All states remain part of the mathematical structure. A past state does not disappear from the equations. It remains a valid solution. From this perspective, physics never destroys the past. It simply moves from one state to another while entropy increases. So the question changes. If physics does not erase the past, then why does it feel unreachable? Why does it feel sealed off? The answer lies in information. As entropy increases, information spreads. It becomes diluted across countless particles. The details of the past are not gone. They are scattered. To reverse time, you would need to gather that information perfectly. You would need to track every particle, every interaction. The laws do not forbid this, but probability does. The number of ways for information to stay scattered is far greater than the number of ways for it to come back together. This makes the past practically unreachable, but not erased. Physics allows the past to exist as part of the system's history, as part of its full description. There is no physical rule that says the universe deletes its earlier states. Time-Sitt's arrow explains change. It explains memory. It explains why we cannot reverse experience, but it does not explain disappearance. The feeling that the past is gone comes from entropy blocking access, not from reality removing it. And that raises the question that physics alone does not close. If the past still exists in the structure of the universe, then where exactly is it? Some physicists take the equations seriously and follow them to their logical end. When they do, time stops looking like a moving thing. It starts to look like a structure. In this view, time is not something that flows. It is something that exists all at once. The universe becomes a single, complete object, every moment included. Past, present, and future are all part of it. This idea is often called the block universe. In a block universe, nothing is created or destroyed by time. Events do not vanish when they pass. They remain where they are in the structure. Change still happens inside the block, but the block itself does not change. Moments are arranged, not replaced. The present is not special in physics. It feels special only because that is where experience happens. The future already exists in the same sense that the past exists. Not as certainty, but as part of the full structure allowed by physical laws. This does not mean everything is predictable. It means everything has a place. The book comparison helps explain this. A book contains every page at once. The first page does not disappear when you turn to the next. The last page exists even before you read it. You experience the story one page at a time, but the story itself is already complete. Time in this view works the same way. Your experience moves through it. Reality does not. This idea feels uncomfortable. It challenges how choice, change, and freedom feel. That discomfort is not a scientific argument. It is a human reaction. Physics does not adjust itself to comfort. Richard Feynman was careful around ideas like this. He did not reject them outright, but he did not embrace them either. Feynman avoided claims that could not be tested. He believed physics should stay grounded in measurement. He focused on what equations actually show and what they do not. From that point of view, entropy has a clear role. It explains why time feels directional, why experience has an order. It explains why memories form, why records exist, why change leaves traces. But entropy does not explain why time exists. It does not explain why there is a past, present, and future at all. It only explains why we move through them the way we do. Feynman made this separation clear. Confusing the arrow of time with the existence of time leads to wrong conclusions. Entropy creates direction, not existence. So when asking whether the past still exists, physics does not give a simple answer, but it does not give a negative one either. Nothing in the equations demands that the past be erased. Nothing requires earlier moments to vanish. Entropy explains why we cannot return, not why the past is gone. Memory is a physical process. It depends on increasing disorder. Disappearance is not. The past may still exist as part of the universe's full structure, just as the future may already exist in that same structure. Access is the problem, not existence. Entropy locks information behind probability. It spreads details beyond recovery. This makes the past unreachable, not unreal. Physics remains silent on deeper meaning. It does not tell us how to feel about this. It only tells us what is allowed, and within what is allowed, the past is never truly ruled out. Time may be far deeper than the way it feels. What we experience as motion may be only our path through something already complete. Entropy shapes that path. It gives time its direction. It creates memory, change, and cause. But entropy does not destroy moments. It only separates them. The past feels gone because we cannot reach it, not because it stopped existing. Physics does not close this question. It leaves space for something stranger than everyday experience. A universe where moments do not vanish. A universe where time is not a river but a structure. This idea challenges how we think about life, choice, and meaning. And it reminds us of something important. Reality is not required to match intuition. If this perspective made you think differently about time, support the channel by liking this video. And if you enjoy deep ideas explained simply, subscribe and stay with us.